Dear students, today we'll see what are actuators. Now, actuators are the output devices. Now, in robotics, if we are studying about robotics, say this is your robotic system. Now, here you are having your robotic system. Then the inputs to the robotic system will be given by the sensors. The sensors are going to give the input, and this robotic system will be having a main component will be called as controller. Now that controller will take these inputs from the sensors. These are the inputs from the sensors, and then it will execute its algorithms along with this inputs and then give an appropriate output, a command to the robot. That means it is giving output to an output device which is called as actuator. Now this actuator will activate the output, and the particular task, the particular application takes place. The particular task is taking place when the actuator actuates. Okay, so this is what the actuator is. So it is a mechanical device or a system which has motion or movement, that is called as an actuator. So actuator will be a mechanical device or a system which can have a motion or movement. Then if you go to see the definition of an actuator is a device that uses a form of power to convert a control signal into mechanical motion. This mechanical motion or movement, anything you can call it. The motion it produces can be either rotary. Rotary means the motion can be rotating like this, rotary, or it can be linear, which can go front and back, linear motion. Then again, actuators, one more definition we will see here. Actuators are the device used for converting hydraulic, pneumatic, and electric. So three types of energy: hydraulic, pneumatic, and electrical energy. When it converts into mechanical energy, it is an actuator. So actuator is the device used for converting hydraulic, pneumatic, and electrical energy into mechanical energy. So we can have some examples in our day-to-day lives, like when you go to any market, shopping mall, or there you can see any grocery store. There you can see you are having the sliding doors. So once you come and stand in front of the door, the doors will open. So this door will open like this door will open like this. That means when the object comes and stands in front of the door, it is sensed by the sensor of the system, and after the sensor of the system senses that there is an object present here, it will control that input. That input will be given to the controller, where a particular algorithm will be processed, executed, and the executed algorithm will give the output to the output signal to the actuator. The actuator will see that the doors are open. This door will be open on this side, and this door will be open on this side with some mechanical arrangement that will open the door, and after the person gets in, again the door is closed. Okay, so this is how the actuator can work as an output device. Then you can also have car seat. The seat can be taken in front and back. You know that according to the person who is going to sit on the seat. You can see here the car seat can be made to move in front, can be made to move back. That is again a output device, which is an actuator, which is making it to move in front and back. Then actuator source of energy, we can have pneumatic energy, which can be converted into mechanical energy. You can have electric energy, which can be converted to mechanical energy. You can have hydraulic energy, which can be converted to mechanical energy. So actuator source of energies are pneumatic, electric, and hydraulic, which can be converted into mechanical movement or motion. Actuators can be classified into following types based on the type of energy. So we can classify them as electrical actuators, as we have named here, electromechanical actuators, electromagnetic actuators, hydraulic actuators, and pneumatic actuators. So from this we are going to study electrical actuators. So electrical actuator, what is an electrical actuator? So electrical actuator is an electromechanical device. So we have named it as electromechanical because the input will be electric energy and output will be mechanical energy. So it is a electromechanical device that converts electrical energy into mechanical energy. So then electrical actuators are of few types, and the main types are shown here. Number one, switching devices. In that you can have mechanical switches like solenoids, relays. You can have solid state switches like your solid state devices, the diodes, thyristors, that is SCRs or TRIACs. You can have transistors like BJT, bipolar junction transistor. Number two, you can have drive systems in which you can have DC motors, AC motors, and stepper motors. Then what are the advantages of having electrical actuators? Now we are concentrating on the electrical actuators which are used in robotics. Okay, so here the advantages are: number one, high power conversion efficiency. So the conversion efficiency from one form of energy to another form. Okay, so that is from electrical energy to mechanical energy, say. Now these conversion efficiency is very high. Number two, the widespread availability of power supply. A power supply is available everywhere. Number three, no pollution of the working environment. Number four, the basic drive element is an electric motor, is usually lighter than that of fluid power. So if you use any other type of actuators like pneumatic, hydraulic and all based as compared to that, the basic drive element in an electric motor is usually lighter. Number five, structural components can be lightweight. Number six, the drive system is well suited to electronic control, which is used most widely in many applications. And one of the important applications as we are studying here is our robotics. Then there are some disadvantages of electrical actuators. Number one, a larger and heavier motor must be used, which is costly. Number two, a poor dynamics response. Number three, a compliance and wear problems are causing inaccuracies. Number four, a conventional gear driven creates a backlash. Number five, electric motors are not intrinsically safe. Number six, they cannot therefore be used in for explosive atmospheres. So these are some of the disadvantages of electrical actuators. Then we will go to see what are the switching device. Then in mechanical switches we have solenoids and relays, and in solid state switches, as I've told you, we can have diodes, we can have thyristors in which we can speak about SCR and TRIAC, and then we can have transistor which will be a BJTs, that is bipolar junction transistors. So we'll start with mechanical switches, and first we'll see what are solenoids. So here mechanical switches in which we are going to study two switches. One is solenoid type of switch and the second one is relay switches. Okay, so here solenoid, if you see, this is a structure of solenoid what we have shown here. So this is your solenoid. Okay, so now here solenoid, if you see, you are having a coil winding here. You can see that there is a coil winding here, and you can see that there is a coil winding here, and in between the space of the coil windings you are having a plunger. Okay, now depending upon the flow of current, that is depending upon the input electrical connection, okay, depending upon the coils inducing the voltages. Okay, now depending on that, the plunger here will make a movement either inside or outside. So you can see this is the movement of the plunger. Either it can go inside or it can go outside depending upon the electrical input which will induce a voltage in the coil, and the current starts flowing around here. So that will make the plunger move, okay, either inside or outside. So that is how a solenoid basic movement can work. So here you can see an image of a solenoid. So this is plunger which will come out and go in after you have an electrical connection. So this is the plunger, and this is the wire which will be having your electrical connection. So depending upon electrical connection, the coils inside will get induced with voltage and current starts flowing, and because of that magnetic lines of force, that force will make the plunger come in or go out. So here you can see one more diagram we have shown here. So here is the coil, this is the induced field inside the coil here. Now in the first diagram we are showing that the plunger is going inside and the current is directed like this, so there is no current as shown in this meter. So current is very less and the plunger is inside. Okay, similarly in the second figure you can see the induced field coil. Okay, in that the current is flowing and the meter is showing that there is more current flowing, and in that case whatever magnetic field developed by the coil will make and force to see that the plunger goes outside. Okay, so depending upon the voltage induced in the coil, depending upon the current flowing, the plunger can be made to come in and go out. This is the basic working of solenoid. So here if you go to see the theory of solenoid, solenoids are actuators capable of linear motion. They can be electromechanical, AC, DC, hydraulic, or pneumatic driven, all operating on the same basic principle. Give it energy and it will produce a linear force. They are great for pushing buttons, hitting keys on a piano, valve operators, and even for jumping robots. DC solenoids operate on the same basic principles as a DC motor. The difference between a solenoid and a motor is that the solenoid is spring loaded and cannot rotate. So it will give you a linear motion. So here next we'll go to see what is a relay. So here you can see an image of relay. So these are your relays. So here you can see the box and here you can see this relay. So here you can see one contact here, another contact here the center contact which is common. So either you can have normally open contact, normally closed contact. Okay, and based on that either it will make a circuit or break a circuit. Okay, so here you can see when there is no voltage applied here to the coil, so even this relay will be having a coil which will be energized. So here you can see no voltage is applied to this coil, and when there is no voltage applied to this coil, that there is no electromagnetic field. So there is no magnetic field here, and the connection from here is at present given to the normally closed type of connection. Okay, so this common point is connected to normally closed. Now what happens if the voltage is given? So when the voltage is applied to the coil here, okay, this voltage will make a current to flow through the coil that will make a magnetic field around it, and because of that magnetic field, the contact which was normally closed will be connected to normally open. So normally closed contact will become normally open. So this is your single pole double throw type of relay working. As an example, we have shown this relay. So when the coil of the relay is energized by an voltage, okay, then the current flowing through the coil will develop a magnetic field, and because of that magnetic field, the contact which was there presently will take another turn, means it will go to the next position. So if it is normally closed, it will go to the normally open point. If it is normally open normally, then it will go to normally closed. Any combination you can have in this relays. So relay can make a circuit or break a circuit. So relay is a switch which controls, that is open and closed circuits electromechanically. The main operation of this device is to make or break contact with the help of a signal without any human involvement in order to switch it on or off. It is mainly used to control a high powered circuit using a low power signal. This is important. Using a low power signal, you are going to make the relay on and off. So here we are using low power signal. So here you can see you are using a low power signal, and with this you are going to make the relay on or off, and that onning and offing of relay will control a high power circuit. So it will be able to control a high power circuit. So that is what the specialty of relay switches. Then we'll go to see what are solid state switches, in which we'll see what is a diode, what is thyristor, and what is transistor. So in a thyristor, we'll see what are SCR, that is silicon controlled rectifier, and we will see what are TRIAC. Now here first we'll go to see what are diodes. So here in this diagram we have shown a voltage source applied here, and you are having a protecting resistor here, you are having a diode here, and then here you are having a load. Okay, now whenever the anode of the diode, this is the anode and this is the cathode, these are the two terminals of the diode. Whenever anode is made positive with respect to cathode, the diode is in forward bias and it is said to be in on position. It is acting as an on switch. Whenever anode is negative with respect to cathode, the diode will be in reverse bias condition and it is taken as an off switch. So this biasing of diode, whether it is in forward bias or reverse bias, makes it on or off, and depending on that, it can be used as a switching device. So here, if you go to see the theory of diode, a diode can perform switching operations between its high and low state impedance. So impedance states, when it is forward bias, it is low impedance. When it is reverse bias, it is high impedance. Okay. Semiconductor materials like silicon and germanium are used for constructing the diodes. These are constructed by joining P and N type semiconductor materials together to form PN junction. It has two terminals, namely anode and cathode. So this is about the structure of the diode. Then when the anode is made positive with respect to cathode and by the application of voltage greater than the threshold level, that is the knee voltage, PN junction is forward bias and starts conducting like on switch, as I've told you earlier. When the cathode terminal is made positive with respect to anode, PN junction is reverse bias and it blocks the current flowing through it, and it acts as an off switch. So when you are having on switch and off switch performance made by this device, it can be used in switching. Then next we will go to see what is silicon controlled rectifier. So here you can see the structure of silicon controlled rectifier. You have four layers. This is P type of layer, this is N type of layer, P type of layer, and N type of layer. You can name them as P1, N1, P2, N2. So four semiconductor layers, and then these four semiconductor layers, because they are joined, they will make three junctions. This is junction J1 between P1 and N1. This is junction J2 between N1 and P2. This is junction J3 between P2 and N2. The terminal which is connected to P1 is called as anode here, which is named as A, and the terminal is which is connected to N2, which is called as cathode K. So this is cathode K. So whenever anode is made positive with respect to cathode, and there is also a third terminal that is called as gate terminal, which can come here. So this will be your gate terminal. Okay. Now whenever anode is made positive with cathode, and if you give a positive gate pulse, the SCR will conduct in one direction. So it is a unidirectional device. It is called as silicon controlled rectifier. This is the IC, whatever is shown. So these are the three R terminals. So these three terminals will be your anode, cathode, and gate. Okay, and here you can see the symbol of SCR. So symbol of SCR shows anode here, cathode here, and gate here. Okay, so if you go to see the theory of SCR, SCR means a silicon controlled rectifier is one of the most widely used high-speed switching device for power control applications. It is a unidirectional device. As a diode, the current will flow only in one direction, in that are consisting of three terminals, namely anode, cathode, and gate. An SCR is turned on and off by controlling its gate input and biasing conditions of the anode and cathode terminals. So the voltage applied to the anode and cathode should be of a minimum value, so that in that case, when you apply the gate input positive pulse, the first and second junction will be forward biased, and the first and the third junction will be forward biased, and the second junction, which was reverse biased, will go into breakdown, and the SCR starts conducting, and then we say the SCR is on. Okay, so SCR consists of four layers of alternate P and N type semiconductor layers, such that boundaries of each layer forms junctions J1, J2, and J3. Then we'll go to see what is a TRIAC. A TRIAC is nothing but an anti-parallel combination of SCR as shown in this two transistor analogy. Okay, so here you can see this is two SCRs connected in anti-parallel. So you have one terminal here which will be named as MT2, main terminal 2. This is one terminal here which can be named as MT1. This you can take it as MT1, that is main terminal 1, and here you have your gate terminal. Okay, so this MT2 and MT1, these terminals can be converted into anode or cathode depending upon the voltage applied. This device is a bidirectional device. That means it can make a current to flow either in this direction if MT2 is positive with respect to MT1, and the current can flow in this direction if MT1 is positive with respect to MT2. Okay, and depending upon the voltage, appropriate voltage applied between MT1 and MT2, if you give a gate pulse, the gate pulse can be positive or negative. Depending on that, the TRIAC can be switched on. Okay, so this TRIAC also will be in on state and off state, and it can be used in switching. So if you go to see the theory of TRIAC or triode AC switch is a bidirectional switching device, which is an equivalent circuit of two back-to-back SCRs connection with one gate terminal. Its capability to control AC power in both positive and negative peaks of the voltage waveform often makes these devices to be used in motor speed controllers, light dimmer circuits, pressure control systems, motor drives, and other AC control equipments. Then we'll go to see what are bijunction transistor, or they can be also called as bipolar junction transistor. So here you can see you can have two types of them. You can have PNP, you can have NPN. So there are two types of BJTs. These are your BJTs. Okay, and that can be also used as switching devices. So here we have taken a NPN transistor. Okay, in the second figure you can show a NPN transistor, and in the third figure you are showing a PNP transistor. This is a PNP transistor, this is an NPN transistor. So here you have shown a switch which is for both the diagrams. So depending upon their polarity, depending upon which transistor, depending upon the base drive, okay, a transistor can be in off mode or on mode. It can go into a cutoff mode or saturation mode. So it can be a on switch or off switch. Okay, so you can use this transistor as a switching device. So here you can see bipolar transistors. Transistor either allows the current to pass or it blocks the current, as similar to working of normal switch. In switching circuits, transistor operates in a cutoff mode for off or current blocking condition, and in saturation mode for on condition. So if it is in a cutoff mode, it is off. If it is in saturation mode, it is on. The active region of the transistor is not used for switching applications. It is used when the transistor is used as an amplifier, but not in the switching applications. Both NPN and PNP transistors are operated or switched on when a sufficient base current is supplied to it. When a small current flows through the base terminal supplied by a driving circuit connected between the base and emitter, it causes the transistor to turn on the collector emitter path. It is turned off when the base current is removed and the base voltage is reduced to a slight negative value. Even though it utilizes small base current, it is capable of carrying much higher currents through the collector emitter path. Then we'll go to see the different drive systems, and in that we'll see what are DC motors, what are AC motors, and what are stepper motors. Okay, now these are motors which will see that the applied electrical energy is converted into mechanical energy. So motors basics, if you go to see, motors convert electrical energy to mechanical energy. So either an AC or DC electrical source can be the input to the motor. The result is mechanical motion of the output shaft, that is a rotation about or a translation along the shaft, provided the load carried by the shaft does not exceed the maximum load that the motor is designed to carry. Okay, so these are the main points, motor basics point. So these are the main basic points where you say the first point as it is a device which will convert electrical energy into mechanical energy, and then it can work on AC or DC electrical energy as it is designed, and it can give a rotational motion at the output. So how to choose a motor? So there are numerous ways to design a motor. Thus, there are many different types of motors. The type of motor chosen for an application depends on the characteristics needed in that application. Now, these characteristics include how fast you want the object to move, the weight, size of the object to move, the cost and size of the motor, the accuracy of position or speed control needed. Depending upon these characteristics, you're going to choose which type of motor you're going to use for a particular application. Then types of motors, if you go to see, the different types of motor poses different operating characteristics. If you are having heavy industrial applications, then you can go for AC motors. If you're having mobile robotics and hobby robots, then you can go for DC motor, DC servo motor and stepper motor. So brief overview of the operational characteristics of AC motors, DC servo motors and stepper motors. Then we'll go to see specifically what is a DC motor. A DC motor will have a positive and negative terminal where you're going to apply the electrical supply. The output of the DC motor shaft will start to spin if we supply a DC voltage to the motor terminal. The speed of the motor shaft can be adjusted because of the voltage across the motor terminals. So here you can see this DC motor here. You can see this winding shown here. Here you have shown a winding. 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 Okay, and this is the rotating part here. So you can have two types of winding in DC motor. One is called as armature winding and the other one is called as field winding. Okay, and both this winding will be having a voltage applied and current will be flowing through that, and one will be made as a fixed winding, one will be made a movable winding. So the fixed winding also will produce a electromagnetic field and the movable winding will also produce a electromagnetic field. Both this electromagnetic field will interact with each other, and in that interaction, in the alignment of that magnetism, the movable thing which is made to move will start moving because it starts aligning itself in the magnetic fields. Then again here we have shown one more diagram where you can see brushed DC motor, that is a DC motor which is having brushes between its electrical connection and armature winding, and brushless DC motor where there are no brushes. Okay, so if you apply a voltage here, then this voltage is applied which is called as VA, and it is applied to the brushes. So here you can see there is a brush here and there is a brush here. These are the brushes, and then this is your rotor, that is main motor inertia. Okay, it is the armature circuit, armature winding, and in between you have your stator, which are your permanent magnets which are fixed. Okay, and which are permanent magnets, and then the magnetic field of the armature and the magnetic field of the field will interact with each other, and in that interaction the part which is made free to move will start moving. Okay, so here also you can see the same type of diagram, only thing the brush is not there in the brushless DC motor. Then we'll go to see AC motors. AC motors are driven by AC current. They are normally used in heavy applications where high torque, high load carrying or load bearing capacity is required. That is why these motors are used in robotic assembly lines deployed in manufacturing units. So even this AC motor will be having something called like armature and field. So here you can call them as stator and rotor. Okay, so stator winding and rotor winding. Stator is stationary, it is not going to move, it is a fixed winding. Rotor is something which is going to move, it is going to rotate. So when you apply the AC voltage supply, so that supply will make the rotor, this rotor will rotate. This is the rotor which is going to rotate, and the stator is one which is fixed. So the magnetic field of the stator and the magnetic field of the rotor will interact, and in that interaction the movable rotor will start rotating. This is the principle of your AC motor. Then we'll go to see what are stepper motors. The stepper motors are DC motors only that can move in discrete steps. This motor is having multiple sets of coils organized in group called as phases. The motor will rotate in each step at a time when you trigger each phase in a sequence. The stepper motors are used where high precision in movement is required. So here you can see the image of stepper motor. So here you can see the electrical connection given input from the controller, and here you can see the rotating part which will rotate in steps. Even here you can see this is the rotating part which will rotate in steps. Okay, so here the stepper motor is a special type of DC motor. It is an incremental, it has an incremental motion, so it is an incremental motion machine. It is a permanent magnet or variable reluctance DC motor and has the following characteristics. It can rotate in both directions. It can move in precise angular increments. It can sustain a holding torque at zero speed. It can be controlled with the digital circuits. So these are the very important features of stepper motor. A stepper motor moves in accurate equal angular increments known as steps. So it will move in steps in response to the application of digital pulses to an electrical drive circuit. The number and rate of the pulses control the position and speed of the motor shaft. Okay, so this is the internal working of this stepper motor. Okay, thank you, students.